Hi, welcome to another video. So there's so many BS videos about free energy on YouTube, I thought I'd do my own. Back in February 2016, I did a video on an ideal boiler and showed a flame sensor and demonstrated the flame sensor was nothing more than like a piece of metal picking up electrons from a flame. But I want to show you today you can get free electricity from a flame. However, it's not strictly free because you have to buy the gas. And since we're in 2022, and certainly in the UK, our gas suppliers don't store the energy. They have to import it at exorbitant costs, and it costs a blimmin' fortune. I've got the same blowtorch I used back in 2016. It's still got some gas in it, not much. So to eliminate some of the mains interference that your body and this scope would pick up, I've grounded this butane torch, regular butane torch. I've got my ground wire here, grounding the metal, and I will demonstrate you get electricity from a flame. Not very much, you can't even light an LED with it. But nonetheless, it's free electricity when you're burning carbon-based fuels. I think it's mostly carbon-based. So here's my scope lead, just so I don't burn the tip. I've wrapped a piece of wire around it, but I want to keep this short, otherwise you just pick up mains hum. You can probably, if I turn the light off for a second, probably see on the scope, you'd see that's mains hum. Let me light this blowtorch and I'll show you how much electricity we can get from this flame. Have a look at the scope as well. It's set to 500 millivolts per division, and have a look at the meter up there, DC millivolts. So as I say, not enough to light an LED, regrettably. My wire is actually melting and I don't want to melt my scope probe. But I noticed when I first offered the cold wire up to the flame, I saw 1 volt on that meter. On average, you get negative 200 to 300 millivolts. I can't make a voltage doubler out of diodes or voltage quadrupler and keep on going up the voltage, because since I've only got 0.2, 0.3 of a volt to start with, any voltage I get from here would be lost across a diode. Let's see what voltage we get on a millivolt scale on a regular digital multimeter. What you couldn't see is I had my ground on the case of this burner and we had over 500 millivolts there. So that's undisputable proof that you get free electricity from a flame. However, you do have to pay an awful lot of money to get that flame, and that free electricity is good for nothing other than sensing those few hundred millivolts, running it to a microcontroller, maybe an op-amp to step up the voltage. You can sense if you have a flame or don't have a flame. And that's how boilers work. Simply stick a piece of metal in the flame. If you've got a voltage, you've got a flame. If you haven't got a voltage, you haven't got a flame. I think you have to be a chemist as opposed to a physicist to understand where the electricity is coming from. That's the basis of gas chromatography. You burn something with a small amount of like air and oxygen and hydrogen, and you measure the ions and electrons coming off the substance, and with a known reference you can detect what you are burning. There is a method you can pass AC current, and when the AC current is passed through a flame, the flame has an effect of partly rectifying the AC voltage. But obviously if we got free electrons in the flame, it's obviously going to bias any voltage flowing through it. So one final demonstration, a blowtorch that I use for heating surface mount components, tiny little flame. So see if I can hold all this. I need that down. We've got there 200 millivolts, 250, 300. Notice my leads are back to front, so if I ground the blowtorch, put my positive lead in front of the flame, so negative 300 millivolts, 400 millivolts. Sadly it's too little to start rectifying and doubling. Otherwise I could store the energy in a capacitor and we could light an LED. This blowtorch is butane. This big blowtorch is a mixture of butane and propane, and they're all carbon based gases. So yes, you can get free electricity if you've already purchased the gas in advance. This is really a bit of trivia. A gas flame is more complicated than you or I would normally think. Hopefully you found this interesting and informative. Thanks for watching.